percentile, 95th percentiles of humans for this particular case. And then also gives you the justification for why you would select a certain type of person. So let's say you're in a situation where you have to lift heavy equipment. So you would put in a requirement that if you're going to carry this, let's say a fuel tank. So let's say an empty fuel tank is, let's say, 10 pounds. But if you're going to fill that fuel tank, let's say it's 60 pounds. Well, there's metrics that say you can't have one person be expected, for the certain percentiles of the humans that exist, within, let's say, a 5, 50, a 90th percentile. You can't have well, in one case, you can go as high as you want, right? You can be as strong as you want, but you can't be too weak. So let's say for the 5th percentile on the size of, how much brawn you have to be able to lift something, you can't expect all people to lift a 60-pound weight. So then they say, okay, this is a 2-person carry. And so that's the kind of thing that comes out of the human factors and anthropometrics. Another term is ergonomics. So ergonomic features is also looking at that same kind of consideration. Anthropometrics with measures and ergonomics in terms of design features. Like some things could be considered ergonomic in the color codes. Do you assign a good status to a red signal? Probably not. I can tell you I've worked with Chinese folks in my past, and Chinese hate the red. If you put red, that means death. So like if you take a red pen and you start putting a red pen, they're doing this. They're hesitant to come close to you because that's bad, right? So you learn that you don't use red unless it's really bad, right? You want to address all the cultures. So obviously, from my perspective, I think yours as well, in the U.S., that red still is maybe not as bad as some people would think, but it's still a warning, right? So you definitely wouldn't want to assign red to something that's like a go condition as opposed to a no-go. No-go, yes, red would be considered.
Either a losing ticket.
So also human-man-machine interface, human-machine interface, HMI, is another consideration that we want to make sure that the way a person interfaces with the machine, with the computer, is easy to do. So one of the things I remember is if you're going to give a computer to somebody that's got to work in the Arctic, and they have to be, it's cold, so they have to be warm. So you got to give them these big warm gloves. But those warm gloves makes your little finger become this big, right? So now you can't be expected to push keys on a keyboard, or let alone a cell phone with all its minor keys, when you got to wear these giant Arctic gloves. So what you do is you design these big interfaces, right, that could withstand, let's say, minus 60 degrees, and then you put big keys on those interface cards. So you might have a board this big, and all it has is 4 keys. Each key is like this big, so you can mash it down with one finger that's that big. So that would be another, ergonomic condition considering the environment that you're in. We'll talk about, we talk about the personnel selection as well. So we talk about ergonomic features, but also for skills. So when we say we're going to select a person based on a skill, you want to put somebody that has a capability to learn, right? So one of the things you do is when you hire somebody, you assess what their capabilities to learn. Not necessarily did they learn something that they could use immediately in your job, but really, I'm going to teach you how to do the job, and I want to know that you have an ability to continue to learn, as opposed to somebody that knows what they know and they don't need to know anymore, right? So I'm going to get a job programming in C. I learn how to program in C, and that's all I'm going to do is program in C. I don't want to learn any other language, right? It'd be good to know that, right, going into a job. What does the person that expects you to do this job expect you to have a capability to do? In other words, am I able to learn any computer language? Just the fact that I know C, does that mean I'm willing to learn any computer language like Java, right, or Ada, if I have to go backwards? I've got some people that used to program in Ada, and they all left the company. There's nobody knows how to do Ada. We have systems out in the field that run on Ada. Who knows how to run Ada? Well, you find somebody that doesn't know Ada, but I'm willing to learn. Well, if you've got nobody that knows how to use Ada, and you got one person willing to learn, who are you going to hire, right? You got to hire somebody. So you want to get somebody that's willing to learn. So human interfaces, human factors engineering considers those things. And it's kind of common sense, but it's also part of what many customers want us to consider. So before you get in front of them. you're thinking about those things. And then the training requirements, what training do I have to do? Some programs that we deal with, they don't want to pay for training, right? But then they're telling you to do something that nobody can do. So if you hire somebody for a program to do one thing that that program needs done, that nobody else needs done, guess what, program, you're gonna have to pay for training, right? Because we'll hire somebody that has a capability to learn it, like we just talked about, but now they're gonna learn something that they're saying they're willing to learn, but they don't know, and they need to know this for them to help you out, do the job you want. So lots of programs will pay for training. They'll justify the need to pay for training. But I've also been a program saying, we're not paying for training. You got to bring us people that are already trained up on what these functions are. So that's another thing that's good to know at the start. Okay, I'm going to talk about chapter 16 now. So just looking at the time, I think I'm on a good trail here. So I've got about 15 minutes left. I'm going to dive into this a little bit more than I have on maybe the previous chapters. This is one that I really found interesting when I was doing the research on this. So software safety, from one point of view, I've been talking about system safety. Now we delve into software safety. What is unique about software safety? And also safety requirements for system versus safety requirements for software. So this chapter we do that. We say, here's how you would write requirements specifically for software. Kind of leveraging what we talked about earlier in the human-machine interface and working with computers. So we kind of touched on it. It's still at a system level, but realizing that the human is now in the loop, and the human is the interface with the machine, and the machine may be a computer. But we're not saying anything about how to design the software yet. Now we're talking about how to design the software so that it's going to be safe, right? Kind of as an evolution of what was in the previous chapter. So that's one piece, is what's unique about software safety. But also, what is the similarities and differences with software safety and software security, or cybersecurity? And so we realize that there's a lot of similarity, but it's like one coin that has two different sides to it. So if you look at it from one side, from the software safety side, is what can I do to my software to make it safer? Versus the other side is what can somebody else do to my software that makes it unsafe? In that course of understanding that and really diving into what that means, right, and exploring this, I realized that there is a difference of what is software, or let's not even say software, what's safety and what's security. What does that mean? They're two different words, right? So I'm going to switch slides and I'll come back to this. So in the understanding of what is safety versus what is security, I found out that in a lot of international worlds, that's the same thing. It doesn't matter. They're synonymous. Whatever you say you do from a safety perspective that we would call safety, they would call that security. And whatever we say we do from a cybersecurity perspective, they still call that security. So we tend to differentiate in the US and maybe in other places like the UK, we tend to differentiate what is software safety, or what is system safety versus what is cybersecurity. We tend to differentiate that. There is little similarity, right, in terms of identifying those failure modes that become weaknesses and vulnerabilities that can be exploited. But in other cultures, doesn't matter, right? So I might say, when I'm in that cave, I'm a caveman in the cave, and I want to be safe, right? Maslow's hierarchy of needs. I want to be safe, right? Before I can have self-esteem, I got to be safe. And I don't put a barrier in my cave, right? So any bear or monster can come in and eat me at night when I'm sleeping. So what we would consider as being safe, some people would say, well, if you put a wall and now you're safe, that's security. From another side, it doesn't matter. Putting that wall is not security, it's still safe. You're safe. How do you feel now? I feel safe. Do you feel secure? Yes, I'm safe and secure. Right? So it's really fascinating when I started reading this. When I first started thinking about this, thinking, yeah, there's a difference, safety and security, because that's the way I was growing up. Difference. Security is kind of like that wall. That wall is my security device. But other cultures say, no, that wall is enabling you to be safe. So you could say the same thing with cybersecurity. Having cybersecurity that prevents a hacker from going in and stealing my personal information or destroying my system and causing it to go haywire where I can't use it anymore, the act of doing cybersecurity design features is strictly security from one aspect. The other one is your computer is safe, therefore you're safe. All the information you got, all your critical program information, all your personal information is safe. Enough on this. Let me go back. So, other parts of chapter 16, we look at software hazard analysis of the software FAMICA. So before we talked about FAMICA in general terms for a system where it doesn't matter whether the function is designed with hardware only or software only or a combination of hardware and software. Here, because of the importance of software we feel in the current state of our complex systems, we thought we would do justice in talking strictly about